Okay.
Okay, Assalamualaikum and a very good day. I am Normiza Muhammad Noor, and today I am presenting on the spike strip ground electrodes. So with me, I have project members, Dr. Nurul Nadia, Dr. Azwan, Nur Farahi, Abdul Wali, and Mustafa Ala Ibrahim Mustafa. So I begin my presentation. The problem statement. As we all know, Malaysia has high yearly lightning flash counts. So if you can see the data here, it shows that just within 4 years, we have close to 4 million total flash occurrence of lightning flash. So these high magnitudes of lightning current, which some studies have shown that it can reach even to 100 kilo amp, this high lightning current needs to be effectively discharged to the ground. So we would need to have an adequate grounding systems so that this current can be discharged to the ground. So as you can see here from the building, then example of a building, and then where this high current need to be discharged to the ground. So the design at the low voltage, which is normally done, is different than what has been observed at high voltage or under lightning condition. This has been discovered since 1928. So it was found that soil would become nonlinear. In other words, if I use the lame term here, it is short circuit, or in other words, this soil actually would turn into a conductor as this high current discharged to the ground. This is because of the ionization phenomena. So let me tell you what ionization phenomena is. As you can see, it can be explained from this simple equation here, where D is the electric displacement and E is the electric field, and epsilon here is the permittivity. So the ionization would be expected to start or initiate from this air voids within the soil. So this will be discharged first, which will turn the soil mass into a conductor. So when it turns into conductor, it makes the grounding systems have better performance. So during ionization process, several streamers would propagate away from this active electrode, which virtually increase the ionization zone. So in other words, it increased the radius or the arcing radius of the earthing systems. So because of this, then it would be expected the ground resistance to be reduced as the currents are increased. However, these are very much dependent on high enough stress, where the high enough stress here refer to a few factors such as the electric field, temperature, frequency, voltage magnitudes or current magnitudes, the time response, and so on. So on the other hand, in the case of extended ground electrodes, or in other words, when we extend the ground electrode, such as to achieve the required value, we would expect to have a large inductive component may be present, because we know that under lightning, we would expect to have of megahertz, or in other words, of microsecond time response. So this, if we convert it into the frequency, they show that it has very high frequency in megahertz range. So this range of values actually give large inductive component in the earthing systems. So due to high impedance, because of the presence of the inductive component, lightning current may not be discharged fully and effectively to the ground. So this, in other words, can cause the back flashover. In other words, it will cause more damage to the equipment. So as you can see here, that this showing or indicate that as you extend the electrode, then the delay in the response due to the presence of the inductive effect. So in other words, that we have seen the effect of ionization and the effect of this inductive component. So some designs of the grounding systems has to be changed. So for this reason, then we come up with our invention, which is pipe strip ground electrode. So we have tested it using the fall of potential method as outlined in IEEE Standard 81 and RDC, where this method of measurement is a standard method widely practiced to obtain the resistance value of the grounding systems. And then we found that just placing the 1.5 meter of our spike strip, we noticed that we obtain 4.2 kilo ohm. Whereas when using the conventional strip, it is close to 100% difference. So you can see here that the spike strip ground electrode is very much effective in obtaining the low resistance value. And other novelty and inventiveness that we have seen in this study is that the COMSOL multiphysics have been used to compute for electric field current. And then we can see here that high electric field, of course, would be expected at the sharp point. So this is very common observation when we have the spike or pointed electrode. So because of this high electric field at the electrode, it can impose high electric field stress on the soil or the surrounding soil. So this will encourage ionization to occur. So as we have seen before, when the ionization process occur, then ionization zone is created, which will turn this mesh soil into the grounding, into the conductor. Whereas when using the conventional copper strip, as you can see here, that much lower electric field is computed as compared to the spike strip ground electrode systems here. So other than those two novelty and inventiveness, as I explained before, you can see that this will be installed downward. So it means that most current and most voltage will be focused towards the lower parts of the soil. So because of this, then it will, the ground potential rise, or in other words, the voltage at the lower part would be higher than at the upper part. So this will be an advantage in terms of the safety, where most currents will be discharged downward. This is a different than on for the conventional copper strip as shown on the right side here. So it doesn't have these safety features for the grounding systems. So the application and usefulness of this, it can be wide range because we know that grounding systems have become integral part of electrical installation and facilities. So it can be installed in as small residential or house owner to as large as utility companies. So we have also planned for the commercial potential and IPR, where it will be commercialized and marketed by our own spin-off company of MMU, which is Grounding Services Sendirian Berhad. And then we are also in the process of signing the intellectual property agreement and a royalty agreement with our TTO office. And as you can see here, this is under review for the IPR protection, which we have agreed to this review between the companies and the university. And then this invention has been filed for patent, which indicate that this invention has not been invented before, and the invention or previous invention has not considered the ionization process. So we managed to get the number for this file, for this patent, as you can see here. So the marketing survey and outcomes, we have approached a few industries, range from the telecommunication to the utility, construction, and so on. As you can see the distribution here, and as you can see that the green chart here shows rather positive. So we have raised a number of questions, and we have seen that the feedback is rather positive among these industry sectors. And for the environmental friendliness, we feel that this invention, when we actually simulated using the current distribution, electromagnetic interference, grounding, and soil structure analysis using Itex, we found that in order to obtain the required resistance value, actually less strips or less electrodes would be needed when using our invention, which is pipe strip ground electrode. So you can see here, in order to achieve 5 ohm, then the number of strips for the pipe strip ground electrode would just be 27. Whereas if using the conventional, it would need more number of strips. So this would require more space, and at the same time, in terms of its technicality, we can see that this will reduce the inductive effect because less materials would be expected to be used. So with that, I end my presentation with a video. Thank you. One way to improve these grounding systems is by considering the ionization process. So in our case, we have invented pipe strip ground electrode, and from the measurement, which is using the IEEE standard 81, we have performed four potential methods, and we found that pipe strip ground electrode has 90% better than conventional electrode. And we have also performed computational method or finite element method, and we have found that the electric from pipe ground electrode is 4 times higher than conventional electrode. Other than that, we have also seen that because of pipe electrode facing downward, most of these currents and voltages are very much concentrated at downward or at this pipe electrode. Therefore, it will reduce the potential rise above the surface or above the surface of the ground electrode.
Okay, our invention has been filed for patent on July 2020, and we are waiting for it to be approved. We also have done the feedback surveys to the industry, and the results are very encouraging. We're waiting for them to discuss further on our invention and discussion about the commercial terms.
This grounding system can be widely used as it is an integral part of electrical installations and facilities. Some examples include utility companies, housing developers, telecommunication companies, food plants, and house owners.
So thank you.